Hi everybody, in this video we're going to practice writing equations with parentheses in them, and then we're going to use that equation to solve a couple of problems. So basically for this first problem and then for this second problem over here, we're going to take the information that's in here to write the equation, and then we're going to use that equation for parts B and C, and we're going to plug this number into the equation to solve for the other variable. So all that'll make more sense as we get started, so let's get started. So we're going to let S in our first equation for this problem be the original price of each shirt, and we're going to let T stand for the total price that Jane will pay. So Jane is just somebody who's going into a store and buying some shirts, okay? The price of each shirt decreased by 70 cents before Jane bought them. Jane bought 4 shirts, and all of the shirts were the same. So we have to take this information over here and somehow turn it into an equation. We're going to write this equation to describe what's going on. So first, let's just make sure that we do understand what's going on here. Jane is walking into a store, right? And she's going clothes shopping. In particular, she's buying some shirts. How many shirts is she buying? Let me stop talking for a second. You read the problem. How many shirts is she going to buy? Well, the answer is 4. She's going to buy 4 shirts. Now, if we just had that information, let's say that S is the price of each shirt and T is the total price, and she bought 4 shirts, and let's go ahead and let's ignore this sentence for a second. Well, then the equation would be pretty simple. The total price would be 4 times the price of each shirt. I hope that makes sense. If S is the price of each shirt and she's buying 4 of them, then, so for example, if each shirt was really cheap and it cost $2 and she bought 4 of them, then what would be the total amount that she paid? It would be $8, right? It would be 4 times the price of 2. That would be the total. So I hope this equation makes sense, that the total is equal to 4 times the price of each shirt, whatever the price is. Okay, except that's not quite the equation that we want to write for this information here, because I ignored this sentence. So let's think about what's really going on here. S is the original price of each shirt, but the price of each shirt decreased by 70 cents before Jane bought them. So instead of multiplying 4 by S, what I really need to be doing is multiplying 4 by S minus 70 cents. So if T and S are written in terms of dollars here, then 70 cents would be written as 0.70, right? If here's 0, when you go to a store, if you see something that's 70 cents, the price would be written like this, right? And that means $0.7 really. And we don't even need this final 0 here, so because 0.7 is the same as 0.70. Okay, so this is our equation. So S is the original price of each shirt, but then the price of each shirt is going down by 70 cents. So really now, after the decrease, each shirt costs S minus 0.7. Okay, and Jane is buying 4 shirts that each cost S minus 0.7. So we have 4 times, in parentheses here, S minus 0.7 is equal to T. All right, so this is how the equation needs to be written. Now I just want to, even though I'm writing it in this space for B over here, I'm not actually solving problem B right now. I just need some more space to write something. What if I had written the equation like this? Is this equation the same as this one? The answer is no. Now, for some problems, for some word problems, you might have to write an equation like this. Okay, equations don't always have parentheses, although in this video, the equations that we're talking about have parentheses. But this is a perfectly good equation. It just does not describe what's happening in this problem. And the reason is this equation is really saying that we take the original price of each shirt and we take the original price of each shirt and multiply it by 4, and then we only take 70 cents away one time, which is not really what's happening here. So if these are the 4 shirts, I think I'm pretty good at drawing t-shirts. I don't know. What do you think? Let's say that, okay, these are the four shirts, and each shirt has a price tag written on it. So the price of each shirt is S. All right, it's S dollars, right? If you want to put a dollar symbol, I'll just put it over there in that one. Okay, we don't know what S is, but each of these shirts cost S dollars. S might be 5, it might be a $5 shirt, it might be a $10 shirt, whatever, right? This equation is telling us to take away 70 cents from the price of each shirt, and to do that 4 times, because all of this is in parentheses. Okay, so each price tag would then say the original price minus 70 cents, which is $0.7. So this is correct for what the problem was talking about, okay? But if we wrote the equation like this, then what we would be saying is that we're buying 4 shirts, but the 70 cents is only taken off of one of them. Because you can see here the 0.7 is not inside any parentheses. It's not getting multiplied by that 4 like this one is. If I were to distribute this 4, I can see it's multiplying the S, and it's also multiplying that 0.7 here. So if I write the equation this way without parentheses, then it's like I'm saying that 70 cents was, that only one of those shirts was reduced by 70 cents, and Jane had to pay full price for the other 3 shirts. Okay, that's not what's being described in this word problem. So I hope now you understand why this equation is the correct equation for this problem over here. Oh, and by the way, I know you're getting so angry at me because I just keep talking until you want me to go on already. But here's another common mistake, so somebody might try writing the equation like this, but this would also be incorrect, because think about it, we're saying that the total price of all of the shirts, we take 70 cents off the total price of all of the shirts, and then we multiply that by 4, and that is equal to, so that gives us the price of just one of the shirts, S. So that doesn't really make sense, right? This way it makes sense. Okay, so now I'm just going to move on to problems B and C here. So I have my equation, and now I can answer, if the total price that Jane will pay is $42, what was the original price of each shirt? All right, so what we're going to do here is we're just going to write the equation out again, exactly the same way. So T equals 4 times S minus 0.7. That's a subtraction symbol there. Now I have to think I have 2 variables here. I have a T and I have an S. Where should I plug in this number 42? In for the T or in for the S? Well, since this problem tells me that 42 is the total price, I'm going to plug it in here for T, which stands for the total price that Jane will pay. So I'll put the 42 in here, not under the S. I'll just keep the S the same. I'm not going to change it. So S is what I'm looking for, right? To answer this question, I have to figure out what the original price of each shirt was, and that is what S represents. So that's what I'm going to have to solve here. Now, there are a couple of different ways that I could solve this equation. I could either distribute first and go ahead and solve it like that, or I could, to begin with, divide both sides by 4 in order to cancel this out over here. So that's what I'm going to do for this problem. In the next problem, I'll answer it by distributing. So remind me in the next problem to answer it that way. So what would I get over here? I would get, so this cancels. So on the right side, I ran out of space over here, so I'll just continue over here. On the right side of the equation, I just have s minus 0.7 left over. I don't need the parentheses anymore because that 4 was canceled out. There's nothing in front of the parentheses anymore. And then 42 divided by 4. Let's see, 4 goes into 40 10 times, and then there would be an extra 2, right? So 4 goes into 2 a half of a time because 2 is half of 4. So on the left side, I'm going to get 10.5, which is 10 and a half. And then the last thing that I need to do, since this is subtraction over here, the inverse of subtraction is addition. So I would need to add 0.7 to both sides. So I would get s equals, and then 5 plus 7. Don't forget to line up the decimals when you're either adding or subtracting. 5 plus 7 is 12. Carry the 1. 1 plus 0 is 1. And then your 1 plus nothing is 1. So s equals 11.2. Let's just make that look a little bit more like a price there. So that means that the original price of each shirt was $11.20. Okay? So let's see if all of this makes sense. The original price of each shirt, we're saying, is $11.20. But we know from the problem that each shirt was decreased by 70. The price of each shirt decreased by 70 cents before Jane bought them. So that means that Jane, when she walked up to the register, really, she only had to pay 50 cents. No, not 50. What am I talking about? $10. Okay, I forgot this 1 over here. Okay. That would be really good if the price went from $11.20 to just 50 cents. No. So she actually, when she went up to the register, only had to pay $10.50 for each shirt. Now, she ended up buying 4 shirts, right? And each one she had to pay $10.50 for because the price was reduced. So, okay, so carry the 2 there. And then 4 times 0 is 0 plus 2 is 2. Well, let me put that decimal in later. And then 4 times 1 is 4. And then I have 1, 2, and then nothing here. So 1, 2. Okay, so that means that the total price that she had to pay when she walked up to the register was $42, which is exactly the number that we were given. So everything you can see makes sense. And this is the correct answer for problem B. All right, so let's move on to problem C over here. So for problem C, we're told the original price of each shirt was $5.45. How much will Jane pay altogether? So now what is the difference between this problem and this problem? Obviously, these two numbers are different, but there's another key difference, which is that in this problem, we are given the original price of each shirt, and we have to find the total price, the amount that Jane will have to pay altogether. Whereas back in this problem, we were given the total price, and we had to figure out the price of each shirt. So we're going to start the same way. We're going to start just by writing the original equation again. T equals 4 times s minus 0.7. But this time, since what we're given is the original price of each shirt, we're going to plug that in for s over here. So, and we're going to keep the t the same. So we have now t equals 4 times $5.45. I'll just write 5.45 minus 0.7. Okay, and then all we have to do is evaluate this. So you can see that the t is already alone on the left side. If the variable that we're looking for is already alone, then we're not going to have to use any inverse operations. So you can see back in this problem, the S was not all by itself, right? We had this 0.7 over here, we had this 4 over here. So in order to figure out what S was, we had to get rid of these two numbers, and to do that, we had to use inverse operations. So since this is multiplication here, 4 times all of this, we had to do the inverse of multiplication, which is division. So that was our first step. And then to get rid of the 0.7, since this was subtraction, we had to do the inverse of subtraction, which was addition. But here, the t is already by itself. It doesn't have any other numbers around it. So we don't have to use any inverse operations. All we have to do is evaluate this side of the equation. So we're just going to use our order of operations, right, PEMDAS, which tells us we're going to do what's in parentheses first. So 5.45 minus 0.7. Let's do that on the side here. Don't forget to line up the decimal. I know so many students would do this, right? But here the decimals are not lined up. If I'm doing addition or subtraction, I need to line up the decimals. So 5 minus nothing now is 5. 4, well, I can't take 7 away from 4, so let's borrow from the 5. That becomes a 4, right? We just reduce this by 1. Then put a 1 next to here. 14 minus 7 is 7. And then, so I'm going to get here 4.75. Okay, and then I still have this 4 here, so times 4. So the total is 4 times 4.75. So let's go ahead and do that. 4.75 times 4, that's 4 times 5 is 20, carry the 2, 4 times 7 is 28, plus 2 is 30, so 0, 3. 4 times 4 is 16, plus 3 is 19, and then 1, 2. I didn't have any decimals over here, so just 1, 2. So I'm going to get $19. So T is equal to 19, okay? So what's happening here is that the original price of each shirt was $5.45, but each shirt's price was reduced by 70 cents. So when Jane walks up to the register, she's really only going to have to pay $4.75 for each shirt. But since she's buying 4 of them, we do 4.75 times 4, and then we can figure out that the total she'll pay at the register is exactly $19, right? Okay, so that's that. Let's do one more problem here. Okay, so in this problem, P stands for the perimeter of a rectangle. So you know what, right off the bat, it's always a good idea to draw a picture. So I'm going to draw let's draw it over here, because I think my face is going to show up over here. Let's draw a rectangle. And L stands for the length of the rectangle. So that means that the length, let's call this the length, and we'll say that this is the width, okay? So the length of the rectangle is L. So from here to here is L. Now we don't know what L is. L might be 5 inches, L might be 20 inches, we don't know, but we're just gonna call it L right now, which means that this side also would be, whatever this side is, then this side would be the same thing. So if this was 20 inches long, then this would also be 20 inches long. And the width, we could write W for the width, but we're actually told in the problem, the width of the rectangle is 4 inches. So we can put a 4 over here for the width, okay, which means that this side is also 4 inches, okay? Now, the first thing we're going to do in part A here is we're going to write an equation that describes this situation, where P stands for the perimeter and L stands for the length of the rectangle. Now, so first of all, what does the word perimeter mean? Perimeter just means the sum of all of the side lengths. So if we do 4 plus L plus 4 plus L, if we add up all of the sides of the rectangle, then that tells us what the perimeter is, okay? So one very simple equation that we could write is just what I said. The perimeter is equal to 4 plus L plus 4 plus L. And that's a perfectly good equation, right? What I'm going to do now is just simplify this a little bit and put parentheses in there, just because the purpose of this video is to give you a couple of examples of situations that can be described with equations that have parentheses in them. But this equation really it's perfectly fine. But just to move ahead here, so I have it. If you look at this, we have 4 plus L written twice. Okay, just to make that more explicit, I could put parentheses around this one, which really doesn't do anything. Okay, so I could write parentheses around here, and I could also write parentheses around here. And then I can see very clearly that what I in fact have is this expression 4L being added to itself. So I have 4L plus 4L. Well, what if I had something like 5 plus 5? What's another way of writing that? Another way of writing that is 2 times 5, isn't it? What if I had something like x plus x? Another way of writing that is 2x, right? So another way of writing 4 plus L plus 4 plus L is 2 times 4 plus L. So this expression is equivalent to the first one that we wrote, 4 plus L plus 4 plus L. It's just written a different way. Okay, so that is our equation. That's the equation that we're going to use for problems B and C over here. And hopefully it makes sense to you if you look back at this picture. Because if I want to find the perimeter of this rectangle over here, one strategy that I could do, like I said before, is just do 4. Let me change the colors here. One strategy is I could do 4 plus, let me change the color even further because those look kind of similar. So again, one strategy that I could do is 4 plus L plus 4 plus L, just like I said earlier. But another thing that I could do is I could do 4 plus L, and since I noticed that really I have another 4 plus L over here, so the length of this that I just drew in yellow is the same as the length of this that I just drew in pink. Another strategy for finding the perimeter is I could do 4 plus L once and then just multiply it by 2, right? So that's what this equation is telling us. We can do 4 plus L and then just double it, and that'll give us the perimeter of the full rectangle. So that's the equation that we're going to use. Now let's use this equation to answer these problems here. If the length of the rectangle is 8 inches, what is the perimeter? So we're going to just write the equation again. P equals 2 times 4 plus L, where the 4 plus L is in parentheses. Now over here, the 8 is the length of the rectangle. So that means we're going to plug it in here for L, not P. Remember, P is the perimeter. So we're going to replace the L with the number 8, and then we'll just write everything out with the L replaced with 8. So we have P equals 2 times 4 plus 8. Now again, just like I said earlier, if the variable that we're looking for, which in this case is P, is already alone, there are no other numbers around it. So remember, it's the equal sign that separates the two sides of an equation, right? The P is on the left side of this equation. There are no other numbers on the left side of this equation. All of the numbers are on the right side. So the P is already alone. That means we're not going to have to do any fancy inverse operations here. We're not going to have to do anything. If we do something to one side, we do it to the other side. We're not going to have to do any of that. All we have to do is evaluate this side. Okay, evaluate the right side over here, which is pretty simple. So 4 plus 8 is 12. So we have the perimeter is equal to 2 times 12. So we just kept the 2 over here. And 2 times 12 is 24. So our final answer here is P equals 24. Let's just throw the inches in there. Okay, IN for inches, because everything is being measured in inches here. Now let's see if that answer does actually make sense. If I go back to this problem, I'm being told that the length of the rectangle is 8 inches. So if I replace the L's with 8's here, then I can see that, yes, I have 4. The perimeter is 4 plus 8, which is 12, plus 4, which is 16. 12 plus 4 is 16, plus 8 is 24. Okay? So if I do add up all these numbers to get the perimeter, then I do actually get 24 inches. Or I could say 8 plus 4 is 12. Okay, and then the length of this is the same as the length of this, so I do 12 times 2, and that will also give me 24. That's more how I did it over here, this way. Now let's move on to the next problem, problem C. If the perimeter of the rectangle is 17 inches, what is the length? So what we're going to do here is we are going to write the equation again. P equals the one that we wrote in part A over here. P equals 2 times 4 plus L. And this time we are being given the perimeter. The perimeter is 17 inches. So we're going to plug that in for P, not for L. So now the equation becomes 17 equals 2 times 4 plus L. Okay? Now, in the last problem, when I had to solve an equation like this, I divided both sides as my first step. I could do that here also. I could divide both sides by 2, and that would cancel that out, and I could continue from there. But I'm just going to solve this one in a different way from the way that I solved it before. I'll start with distribution, like I promised I would do earlier. So I could do 2 times 4, which is 8. And then 2 times, luckily, this is pretty easy here. I have a positive 2, and this is a plus sign. So I'm just going to write plus 2L over here, 2 times L, so 2L. So I have here 8 plus 2L equals 17. Let me rewrite that all over here, because I kind of ran out of space. 17 equals 8 plus 2L. Okay, the next thing that I need to do is either get rid of the 2 or get rid of the 8. I'm going to choose to get rid of the 8 first. Now remember, if you do not see a symbol written in front of some number, then you can put a little plus symbol in there. And then I can see that to get rid of the 8, I would do, this is addition here, so I would do the inverse of addition, which is subtraction. So I would subtract 8 from this side and then do the same thing to the other side. Let's subtract 8. And over here, we would get 2L. I don't have to copy this plus sign. If it were a minus sign, that would be important. I would have to copy it. But I don't have to copy that one. 17 minus 8 is 9. Okay? And then the last thing that I need to do, since this is really 2 times L, that's multiplication. The inverse of multiplication is division. So we're going to have to divide both sides by by 2. And we would get L equals 9 divided by 2 is 4.5, so 4.5. Now let's go ahead and see if this answer makes sense. So we just figured out that the length of the rectangle is 4.5 inches. So if the length of the rectangle is 4.5 inches, I'm not drawing this to scale, obviously, because if this is 4 inches and this is 4.5, this should not look so much bigger than this side because it's only half an inch longer. But anyway, let's see. So I have, let's do it this way. 4 plus 4 is 8, and 4 plus 5 plus 4 plus 5 is 9. So I have, if I add all of these, then I'm adding 8 plus 9, which is 17, right? So the total perimeter would be 17 inches, which is exactly what it said back here. The perimeter is 17 inches. So it all makes sense. So this must be the correct answer. If the perimeter is 17 inches, then the length of that rectangle must be 4.5 inches. Okay? All right. So I think that's it. We're done. I hope that was enjoyable. I know it was long. Sorry about that. But anyway, have a great day.